Okay, 43. When asked to explain the meaning of the p-value um, was p equals zero point 0.3, student says this means there's a probability of 0.03 that the null hypothesis is true. And the answer is that is false. Explain what p equal 0.03 really means in a way that makes it clear that the student's explanation is wrong. Well, we got h0, mu equals something, and ha, mu is less than that something or greater than that something, or we even have not equal to that something, okay? Which we'll talk about a little bit later here. Now, the p-value, well, first of all, I take a sample and I get my sample, and we've been talking about this. Hopefully, it's straightforward for you. But I take a sample and I get x bar. Okay. If mu is, if we assume mu is true, h0 is true. We're assume true. Then the sampling distribution is approximately normal, with mu x bar equal to mu and sigma x bar equal to sigma over the square root of n. And then x bar is a data point, a value here on this in my um, sampling distribution. And the p-value is the probability that I get a sample with value x bar or more extreme. It has nothing to do with the probability of h0 being correct or not. It has to do with the probability of getting a sample as extreme as x bar. Okay, so that's the p-value. Okay, probability of getting a sample this extreme. Okay, as x bar. Okay, 45. Oh boy, I don't know how to say that. Cicadas. As fertilizer, every 17 years, swarms of these guys, these bugs, emerge from the ground in the eastern United States, live for 6 weeks, then die. There's so many cicadas in there that their dead bodies could serve as fertilizer. In an experiment, a researcher added some under plants in the forest, leaving others undisturbed. In this experiment, cicada supplemented produced foliage with a 12% greater nitrogen content relative to controls, so the non, with a p-value of 3.1%. So the p-value is 3.1%. So that's considered extreme because it's less than 5%. So that means my sample did not happen by chance. Okay. Colleague who knows no statistics says an increase of 12%, which is what we got, isn't a lot. Maybe it's just an accident due to natural variation among the plants. So he's saying that it's the extreme value is due to sample variation. But we know that there is only a 3.1% chance of getting a sample that extreme. So the question is, how do you combine these two? He says it's sample variation. You say with the p-value that there's only 3.1% chance. I wouldn't call this normal sample variation if it only has a 3.1% chance of happening. That doesn't fly with just normal sample variation. This is just not likely to happen. So that would be evidence that there's a change, that there really is, this supplement really does do something. Didn't just happen. Okay. 47, 5% versus 1%. Sketch a standard normal curve. Okay, b mu equals 0, sigma equals 1. For the z-test statistic and Markov areas under the curve, show y value significant at the 1% is always significant at the 5%. Well, here is 1%, and then this area here, if that's 5%. If you get a z score that's significant at the 1%, is always significant at the 5%. That means if it's significant at the 1% level, that means z is anywhere in this range over here, right? So that means the area to the right of it has to be less than 1% or equal to 1% to be significant at the 1%. Significant at the 1% means that it has a 1% chance or less of happening. Well, if it's over here, then certainly it has less than a 5% chance of happening. Okay, so significant at the 1 means it's always significant at the 5%. Now, what about the other way? If it's significant at the 5% level, meaning, say it's this point right here, there's a 5% chance of it happening or more extreme. Or I'll go different. Oh, my colors are hidden, sorry. If there's a 5% chance of this happening, does that mean it's significant at the 1% level? And the answer is no. Because if this is my value here, I've got, 5 out of 100 chances that I'm going to get a value that extreme or more. But to be significant at the 1% level means you have to have a 1 out of 100% chance, 1 out of 100 chance of it happening by random chance. That's got to be below this value here and be in this range. So here it's not significant at the 1% level. Here it is. Okay. And last but not least, 55. And you know what? I'm going to start this on a different video. There we go.